AC and DC coupling offers different advantages depending on the type of plant and its environment. How do you decide which strategy is best for your solar or hybrid project? Today we will look at specific cases including new construction, retrofits, microgrids, and regions with grid saturation. Stay to find out which strategy can maximize the efficiency and profitability of your project. DC coupling is a highly efficient solution for solar power projects designed from scratch, as it allows the infrastructure to be optimized from the initial phase. By reducing the energy losses associated with direct current DC to alternating current AC conversions, this approach significantly improves overall system efficiency in new projects, such as large capacity PV plants, greater than 50 megawatts. DC coupling eliminates the need for multiple conversions, allowing power to flow directly from the solar panels to the storage systems. This results in higher energy efficiency and lower losses during the generation and storage process. This system is especially beneficial in regions with high solar irradiance, such as Andalusia or northern Chile, where energy generation can be maximized and losses minimized. These locations allow optimizing both production and storage, increasing the plant's total yield. The technical and economic benefits are reduced operating costs. Fewer conversions means less equipment, reducing maintenance and operating costs. Increased return on investment. IRR maximizing energy efficiency increases net energy available for sale, improving revenues. Shorter payback period. Increased efficiency and reduced costs allow the investment to be recovered in a shorter period of time. Short. DC coupling is a strategic option for new projects, maximizing efficiency, reducing costs, and accelerating profitability from the start. AC coupling is an efficient and practical solution for retrofitting solar plants already in operation, allowing the integration of energy storage systems, BESS, without significant modifications to the existing infrastructure. This strategy is especially useful in projects where operational continuity and time optimization are critical factors. One of the main advantages of AC coupling is its ability to add energy storage systems to existing solar plants without intervening in the DC infrastructure. This facilitates fast and efficient integration, minimizing disruptions to plant operation and reducing the costs associated with system reconfiguration. Key benefits are independent operation. Both the solar system and the BESS can operate independently, allowing for greater flexibility in energy management. This is especially useful for adjusting generation and storage according to market demand. Reduced integration times. By not requiring extensive modifications to the DC infrastructure, installation and commissioning times for the storage system are significantly reduced, allowing for fast and effective retrofitting. Increased operational flexibility. AC coupling allows for better energy management during peak demand, storing surplus production for later use when energy prices are higher or demand requires it. A case study is the retrofit of a medium-scale solar plant in a dynamic market like Texas, where price fluctuations are common. Integrating an AC-coupled storage system allows taking advantage of price spikes, maximizing profitability, and improving responsiveness to changes in demand. In summary, AC coupling is an effective strategy for retrofitting existing solar plants, offering simple integration, greater operational flexibility, and rapid adaptation to energy market conditions. Direct current DC coupling is an ideal solution for microgrids and community projects in rural or isolated areas, where connection to the conventional power grid is unfeasible or unreliable. This approach optimizes both the capture and use of renewable energy, maximizing efficiency in environments with limited resources and high energy autonomy needs. In rural or remote communities, DC coupling allows energy generated by renewable sources, such as solar panels, to flow directly to storage and consumption systems, avoiding significant losses in power conversion. This is critical in off-grid projects, where every kilowatt-hour counts to ensure stable and efficient operation. Additional benefits are compact design and simple maintenance. DC coupling systems require fewer electrical components, resulting in a more compact design and simplified installation. In addition, the reduction of moving parts and complex equipment reduces the need for frequent maintenance, which is key in regions where access to technical services is limited. Reduced operating costs. By minimizing reliance on diesel or other fossil fuel generators, DC-based microgrids significantly reduce operating costs. This not only improves the economic sustainability of the project, but also contributes to a lower carbon footprint, aligning with global energy transition goals. An illustrative example is the implementation of a microgrid in a remote community in Africa that combines solar energy with an energy storage system, BESS. This configuration ensures a stable 24-hour power supply, providing continuous access to clean and reliable energy to cover basic needs such as lighting, food refrigeration, and access to communication services. In conclusion, DC coupling is a key solution for microgrids and community projects in isolated environments, offering energy efficiency, reduced costs, and an adaptable design that ensures a stable and sustainable power supply. In regions where the power grid is saturated or has limitations to integrate new energy sources, a hybrid strategy combining direct current, DC, and alternating current, AC, coupling is positioned as an effective solution. This configuration maximizes the utilization of generated energy, optimizes storage, and improves operational flexibility in complex and congested environments. When the power grid cannot absorb all the energy generated by renewable plants due to saturation, a hybrid strategy allows to efficiently manage generation peaks and avoid energy losses. The combination of DC and AC coupling systems facilitates both the storage of surplus energy and participation in grid ancillary services, such as frequency regulation. The benefits of the combination are DC coupling for surplus storage. The DC coupling system efficiently captures generation peaks that cannot be immediately injected into the grid. These surpluses are stored in batteries, BESS, allowing for later use when demand or prices are more favorable. AC coupling for operational flexibility. The AC connection allows direct interaction with the grid, facilitating participation in frequency regulation and ancillary services markets. This not only improves the stability of the power system, but also increases opportunities to generate additional revenue. Some of the expected results: reduced energy discharge. By storing surplus energy instead of discharging it to the grid, energy losses are minimized, optimizing the use of renewable resources and improving overall system efficiency. Increased revenues. The combination of efficient storage and operational flexibility allows energy to be sold during peak demand, when prices are higher, thus increasing project revenues. In summary, a hybrid AC and DC coupling strategy is a key solution in regions with high grid saturation, allowing for more efficient energy management, better integration of renewables, and maximization of revenues in dynamic markets. There is no one-size-fits-all solution. Choosing between AC, DC, or a hybrid strategy depends on the type of plant, the environment, and the project objectives. Bottom line, for new construction, DC to maximize efficiency. For existing plants, AC for modernization without major alterations. For microgrids, CC for isolated communities with focus on self-sufficiency. For saturated regions, hybrid to mitigate spills and maximize revenue. If you need help designing or choosing the best strategy for your solar or hybrid plant, contact me on LinkedIn. Let's make a more efficient and sustainable energy future a reality. And don't forget to subscribe to the channel for more content and to keep learning about BESS systems.